This video covers the unit circle. It starts out with the basics, and towards the end of the video, we actually construct the entire unit circle with the respective angles and their x and y coordinates. So first of all, what is a circle? Well, a circle is simply a two-dimensional shape that consists of all the points that lie a given distance from the center. And so as you can see, we have the center in the middle of the screen, then we have a circle drawn around it. And so you likely know this definition, but there's also a couple terms we have to know before exploring this in more detail. So the diameter. The diameter is a straight line segment that passes through the center and whose endpoints lie on the circle. And then the radius is simply half the length of the diameter. So the radius is a straight line segment that passes from the center to an endpoint on the circle. And these two definitions are very important. In trigonometry, the radius is used much more than diameter, and so we'll be focusing more on the radius. But the radius can also be used to determine the circumference. And so the circumference is just the perimeter of the circle. It's the length of this green line right here. Well, these three different definitions can be represented with equations. So for example, the diameter is 2 times r. It's twice the length of the radius. The circumference is 2 times pi times r. And this equation would require a proof, which we're going to avoid in this video, but just understand that the circumference is 2 pi r. And then the radius is just half the length of the diameter, so d divided by 2. And so notice how the diameter and the radius are kind of dependent on each other. They're kind of cyclical functions in a way. It's kind of like energy and mass. Energy depends on mass, mass depends on energy. Well, these equations depend on each other, so you have to know at least one quality to determine the other two. So if I give you the diameter, you can determine the radius by dividing it by 2, and you can use that radius to find the circumference, 2 pi times r. And so these three equations are very important, and they will show up quite a bit as we work with the unit circle. So what is the unit circle? Well, it's simply a circle whose radius equals 1. And what's the point of this? Well, the idea is to simplify the mathematical model. And so by making the radius equal to 1, it makes all of these values very simplified. The radius equals 1, therefore the diameter equals 2, and the circumference is just 2 times pi times 1, which is 2 pi. And so in the unit circle, all these numbers are much easier to work with. We can represent trigonometry and all these different things that we're going to be exploring in much simpler terms. And that is why we like to use the unit circle. And there's also other uses that I will show you very shortly. But before moving on, let's explore what angle measure is. So angle measure, a circle consists of 360 degrees, but in trigonometry, we don't like to work with degrees. We like to work with something called radians. And so a radian is simply a different unit for angle measure. It's just a unit that represents angle measure, but it's different than a degree, and it can get a little confusing. So keep in mind that half the length of a circle is 180 degrees, and the whole way around is 360. Well, a circle consists of 2 pi radians, and so half the length of a circle is pi radians, right? And so a radian, again, is just a unit for angle measure, and we have these simple conversion factors. So notice that pi radians is equal to 180 degrees, and so if you remember this unit conversion, it's very simple to convert between degrees and radians. And as you work with the unit circle, you will eventually learn how to work with the radians much easier. And if you're a little confused on what a radian is, it's simply a different unit for angle measure. There's a degree and there's a radian. It's just a different unit, just like there's a foot and there's a meter and there's a yard. It's just a different unit. And so don't overcomplicate the situation. Now in your homework, you might often come into a question of, well, I give you 120 degrees, what is this in radians? Well, we can just use the unit conversion, pi radians over 80 degrees. Notice the degrees cancel out, and we're left with radians in the numerator. If we multiply it out, we get 2 pi over 3 radians. And do not forget your units. And so what I want you to do is to quickly determine what 2 pi or 3 pi over 2 radians is in degrees. And so convert 3 pi over 2 radians to degrees. Okay, and if you did that conversion, you likely used the unit conversion I showed you, but in the reverse order. And you can use your calculator to verify your calculation. Okay, so you likely saw this in your textbook or in your class, and you're probably like, well, what in the world is this? How do I memorize the entire unit circle? It looks extremely complicated. And that is completely true. As you can notice, there's lots of different values. We have things represented in degrees and in radians, and there's a lot of stuff going on, and it's like, well, this is confusing. Luckily, you might have some questions. How do I learn this? Why is this useful? Well, let's take a look. So how do you learn this? A few different ways. Number one, there's something called special right triangles. And by utilizing these triangles, we can determine the common angles and their respective coordinates. And by using these right triangles, we can also combine this with something called patterns. And by using these patterns, we can determine angles that have similar features. And I will show you all this in more detail very shortly. And of course, there is memorization involved. I would be careful. I would not try to memorize the entire unit circle. I would memorize some of the really common coordinates and then use patterns to determine the rest of the unit circle. And I'll show you all of this very shortly. So why is this useful? Well, it allows for quick calculations of sine, cosine, and tangents. You have likely learned these before, but if you have not, I'll explain them very shortly. But the whole idea for the unit circle is you can just calculate these common values really quickly. It also relates to sinusoidal graphs and functions. You can map the unit circle to a sine graph, and you can notice complete similarities, and you can notice that if you know the unit circle, you can plot common points on the graph very quickly. And so there's a very close correlation. And also, these values of sine, cosine, and tangent are used extensively in any STEM major. So of course in mathematics. In engineering, it's used all the time. And same thing with technology and computer science. You'll be running into sine, cosine, tangent in a lot of the work you do. And then of course in medicine and science, these values also show up. And then if you watch this video, you will soon become a sensei. So, before we get to the unit circle, what are the sine functions? Well, we have sine, cosine, and tangent. These are just functions, and they're basically ratios. And so look at this triangle at the bottom of the screen. Notice we have the angle theta labeled in the bottom right. And we have these three different sides. We have the hypotenuse, which is opposite the right angle. We have the opposite side, which is opposite theta. We have the adjacent side, which is the side that touches theta, but is not the hypotenuse. And so we can represent these three different ratios as equations. Sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. And tangent of theta equals opposite over adjacent. Okay. Well, in the unit circle, let's just kind of think about this. Let's go ahead and map the unit circle on the screen. Okay, well, notice how theta becomes the center of the unit circle. The hypotenuse becomes the radius. Well, we know that the radius of the unit circle is equal to 1. Therefore, the hypotenuse is equal to 1. And so, sine of theta simply becomes opposite over 1. And so sine of theta is opposite. Well, if you look at this picture, notice how if we map the opposite side up into the endpoint of the circle, it actually represents the y value of the coordinate. Same thing with cosine, adjacent over 1. So cosine of theta is adjacent. Adjacent is the x coordinate. And so the cosine of theta is represented by the x coordinate on the unit circle. Okay, so sine of theta is y, cosine of theta is x. Okay, well that simplifies this entire mathematical model extensively. By using a unit circle, we make the hypotenuse 1, and we simplify these ratios, and we can represent the values of sine, cosine, and tangent in simpler terms. And to do so, we have to utilize special right triangles. And so we have two different types, the 45-45-90 and the 30-60-90. Notice that these angle measures add up to 180 degrees each. So if we look at this triangle on the right side, we have the 45-45-90, and notice the pattern. If you're given x on either leg, then the hypotenuse is just x times the root of 2. Well, in the unit circle, we know that the hypotenuse is 1. That means x is equal to, well, let's solve the equation, 1 divided by the root of 2. If we go ahead and radicalize the bottom, we get a nicer looking expression, the square root of 2 over 2 for both legs. And so in a 45, 45, 90 triangle on the unit circle, the value of sine and cosine will be root of 2 over 2. Because remember that sine and cosine in the unit circle are just the x and y coordinates, or the y and x coordinates. So that is self-explanatory. So how about you go ahead and try to fill in the 30, 60, 90 triangle. And just keep in mind that 2x equals 1, right? The hypotenuse equals 1. And so x equals what? 1/2. Okay, so we know that one leg. And the other leg, think about it. Okay, it's just 1/2 times the square root of 3. So the root of 3 over 2. Okay, so let's go ahead and start to calculate some values on this unit circle. So notice how I kind of mapped a triangle on the unit circle that kind of represents a special right triangle, either the 30, the 60, or the 45. But one of the issues is that when you work with either a coordinate like 0, 0, or 1, 0, or 0, 1, any coordinate that lies on an axis, you can't use a triangle, right? So for example, let's go ahead and look at this angle, 0 degrees or 0 radians. What is the x and y coordinate? Well, we can't use a triangle, but it's the same thing as what you'd imagine, right? So the x value is 1, the y value is 0, so cosine is 1, sine is 0. Okay, well, that's self-explanatory, right? So the cosine of 0 radians is 1, the sine of 0 radians is 0. And again, notice a triangle on the right side. You can't quite use a triangle in this situation, but it does not matter. It still works the same way. Now let's look at pi over 2 radians, or 90 degrees. What's sine and cosine? Well, we know that the coordinate is 0, 1. X value is 0, y value is 1. And so, sine of pi over 2 is 1. Cosine of pi over 2 is 0. And think about this one. Okay, so we have 180 degrees, or pi radians. What's the sine and cosine? Well, it's just -1, 0. So cosine is -1, sine is 0. 3 pi over 2, that's 270 degrees. Cosine is 0, sine is -1. And so this situation is relatively simple. However, things can get a little more complicated. What if I ask you, what is the sine of 5 pi over 2? Well, okay, so notice something here. We have 5 times pi over 2. Okay, that's very interesting. So we have basically 5 revolutions of pi over 2, right? So if you look at this unit circle, where does this point lie? Well, let's go ahead and trace our steps. We start out with 0 degrees. We then have, which is 0 times pi over 2. We then have 1 times pi over 2. 2 times pi over 2, 3 times pi over 2, then we have 4 times pi over 2, which is the same thing as 2 pi. And then we have 5 pi over 2. Okay, that's what we're looking for. And we notice that the sine is 1, the y coordinate. And so to determine these more difficult looking values, use a pattern. Notice how it's 5 times pi over 2. Well, we know what pi over 2 is. It's just 90 degrees. And so we go 90 degrees times 5, so 1, 2, 3, 4, 5, and we end up at this specific value. And the sine is the y coordinate, which is 1. Okay, well, let's go ahead and fill out some more. Let's fill in the quadrant 1. So we know 0 radians, we know those values, we know the values for pi over 2 radians. What are these other values? Well, notice how pi over 6 is actually 30 degrees, pi over 4 is 45 degrees, and pi over 3 is 60 degrees. Well, we can use these special right triangles to determine the values. And we already did. On your other sheet of paper, we already filled out the special right triangles. And so we know, using these two triangles, that 30 degrees has a x value of root 3 over 2 and a y value of 1/2. And we know the 45, 45, 90 right triangle, both legs are both root 2 over 2. And then for the 60, is just the x value is just 1/2 and the y value is root 3 over 2. And so using those special right triangles, we can fill in these values. Okay, well, now let's go ahead and fill in quadrant 2. Well, to do so, let's use patterns. So if we simply reflect the values over the y-axis, it makes things much easier. All you have to do is make the x value negative and keep the y value positive. And another technique is called increments. Count by increments of an angle you know. So there's some different ways to tackle this. Let's go ahead and start out with the angle of pi over 3, right? See pi over 3 in the quadrant 1. Reflect this over the y-axis. You end up at 2 pi over 3. Well, it's the exact same value, but the x value is negative. So negative 1/2 comma root 3 over 2. Okay? And again, the reference triangle goes from the x and y coordinate down to the x-axis. So you have to fill in that triangle just like we did over here. See that triangle, how it starts at the x-axis and goes up to the point? Same idea for this page over here. And so, let's think about this. Okay, so we got that value. Now let's go ahead and try 3 pi over 4. Well, it's just the reflection of pi over 4. Just make the x value negative. Same thing for this value. Let's also notice that we can use some increments. Before doing so, I'd like you to fill in quadrant 3 and 4 using the reflection idea. So for quadrant 3, reflect quadrant 2 over the x-axis, and then for quadrant 4, reflect quadrant 3 over the y-axis. And by using reflections, you can get these values. But you might be wondering, what are the angles? So I can fill in these values just using reflections, but what are these angles? Like, where is 7 pi over 6? Where is that angle? Well, this requires increments. So notice in the quadrant 1, we have pi over 6, right? Well, let's go ahead and count by increments of pi over 6. Pi over 6, 2 pi over 6, same thing as pi over 3. 3 pi over 6, same thing as pi over 2. Keep on counting. Okay, 6 pi over 6 is the same thing as pi, which is just a negative x-axis. And then 7 pi over 6 ends up right there. Okay, and what is the sine and cosine of 7 pi over 6? Well, just reflect 5 pi over 6 over the x-axis. As you can see, that would end up in this exact location. And all you do is make the y value negative. So it's just negative root 3 over 2 comma negative 1/2. Okay, so easy enough. If you have any questions, please let me know in the comments, and I will happily get to them.